Hello everyone, welcome to yet another learning video. My name is Ravi Sharma and today we are going to explore Oracle's Vision AI service offering. We'll try to understand what it actually does and how can you leverage it to create your own custom solutions. Before we get started, let's have a 1,000 feet view of where exactly the Vision service fits in the whole Oracle ecosystem, right? And as you can see in the slide, Oracle Cloud is enabled with AI at various levels. The AI infrastructure provides a robust hardware platform which can process the demanding AI workloads. And these work on the backbone of cutting edge NVIDIA processors, the OCI superclusters, and whatnot. On top of the data that resides on the hardware are AI-enabled data platforms. These products not only offers fully managed services that can be used to build, train, and manage your ML models, but you can also query data based on semantics rather than keywords, right? So imagine an SQL query in which you have where clause where name like something XYZ, right? In AI world, the data is queried on semantic basis, mostly using LLMs, etc. So these products enable that kind of search where user can just put a blind query in the system and say, what is the status of my XYZ order? Or you can just query your database to, get top 5 employees with maximum salary. You don't need to be an expert in PL SQL, right? A layman user can do that, right? Now, with this, we finally come to the AI services layer. Oracle AI services are a collection of, a wide variety of offerings, and these provide you out-of-box pre-built machine learning models that can make it easier for developers to apply AI to applications and business operations. The models can be also custom trained, so it's not that you must use the out-of-box models. You can create your own custom models on top of that, and it can be fine-tuned more accurately to your business needs. Right? And as you can see, it offers a wide variety of solutions like speech to text conversion, your language detection and sentiment detection. You have document understanding where you can provide a document to the service and it can intelligently decide if it's an invoice, what are the parameters which it carries, what are the values of different attributes, etc. And you have your digital assistant, which is in the backbone. It has the machine learning enablement, right? In addition to that, you have the latest offerings of our OCI generative AI as well as the Gen AI agents, right? So for this session, we are focusing on the Vision AI service. So let's get started. Once you log into your OCI console, you can see all the Oracle AI services clubbed together under Analytics and AI. As you can see, you have generative AI, language, speech, document understanding, and whatnot. And of course, we have Vision. So let's go there. On the Vision homepage, there are several useful links where you can see some workshops, documentation links, etc. And then there are a few, the supported features of what you can accomplish using the Vision AI service. Before we deep dive into the different features, I'll just show you the important link, which is our documentation. Once you come here again, you will find several useful links. And a few of them are like the live labs. Here you will find demonstrations of how you can implement different features. You have SDKs and the CLI link for all the developers. And the most important is the Vision API link. If you hit this link, you will be navigated to the API references of Vision API, right? And we will discuss more about this in detail in a few minutes. First, let's get back to the OCI console here on the Vision page. On the left-hand side, these are the features which are listed below. So let's get started. The first one is image classification. So as soon as you land here, you will see a sample image being displayed. And the image classification model is trying to analyze different entities in this image, and they are referred as classes. On the right hand side, you will see that there are 5 classes or entities being detected by the model, and at what confidence level they are being detected. So, in the world of machine learning, as you know, confidence score is important to show at what accuracy is the model performing, right? And here you will see these sample images are picked up by Oracle automatically, and where they are coming from is what you will find in the request payload here. So it's so convenient to have the request payload required by the image classification feature of Vision service, right? And as you can see here, this is the compartment ID which is being used. And inside the image object here, you will see that the source is object storage. And these are internal namespace and the bucket name of Oracle, which is being referred, and the name of the object which is being referred. Okay. In real world scenario, when you are implementing your solutions, you can choose your own object storage location as well as the object name dynamically, right? So this sample payload helps you create your own applications which can call this service and make it work, right? Now, if I go down a bit, you will see something called features, right? Within this image, what all features you want to determine, you want the Vision API to determine for you, right? So in this particular example, the feature type being used is image classification. What other feature types can we expect? So let's go to object detection. And again, a sample image is loaded and analyzed. And here, basically, instead of different classes, you are being shown different objects which are identified in the image, right? If I expand the request, you will see that the feature type is object detection rather than image classification. The rest of the request payload looks pretty similar, right? So it's so convenient that it depends upon your use case. You can upload an image and what kind of detection you want that you can pass as a feature type, right? Coming to the response here, you will see that the response for an object detection will have the objects listed here with their respective confidence score, along with the XY coordinates within the image, so that you can, if you want, you can use them to draw polygons on your application, right? So it very beautifully shows rectangles around the objects, and like these two persons, which are not easy to make out with the naked eye, the machine learning model was able to identify. Now the response structure will be completely different for the image classifications. If I go back here, your response will have labels rather than image objects, right? And then you have ontology classes. So ontology classes are there even in the object detection. These are nothing but a way for the model to tell you that what object or what class belongs to what parent class. So vegetation belongs to plant. So as simple as that, right? And then there is other metadata as well, like the model version, etc. Right? So let's quickly go to the face detection. This is one of the latest features of the Vision API, right? It determines if the image has faces, and there are um, few key elements in an image that it needs for it to make sure that's a face, like the eyes and the nose tip. Then you have the ends of your mouth, right? So in the request payload, you will see again it's exactly the same payload. It's just that the feature type is different. And there is again an additional parameter which is specific to your face detection. In the response, it is very specific to the face detection service, right? Feature rather. So detected faces, and then you have your XY coordinates, right? And then on that particular face, where exactly is the left eye, nose tip, edge of the mouth, right and left. Similarly, you will have for all the faces detected in the picture, right? So at the end of this video, you will also see a demo where I'm doing an image classification. So let's see um, what classes are identified from an image that I upload from my local system. So as you can see, there are different classes which are identified, and in the request, you will see that instead of object storage, the source is inline, and the data basically it's showing dot dot here, but it's the binary representation of the image that we need to pass here, right? We'll see that in a moment. Now, last but not the least, you will have something called text detection. In a given image, if it's able to see that there is some text available, that will be shown to you. Now, there are two ways in which it shows you the response, or rather, both the extractions are available for you. You can either read the data in line format or word format, right? So the belt root is divided into words right here. In the request, again, it's exactly the same request, just that the feature type is different. It's the text detection, right? And again, in the response, you will have your polygon XY coordinates, and then what kind of, within the word, what is the text, right? And so on and so forth, right? So now let me take you to the API page, and let's see what it has to say about different APIs. At the home page, you will see all the different endpoints which are supported by the Vision service, and these are nothing but the different regions in which this service is deployed, right? So in case of GenAI service, we saw in another video that it was available only in 4 regions, right? But this Vision service is available across so many different regions, right? So the URL that you will need to use in order to invoke this API will start with this, right? Now, here on the left-hand side, you will see what all different operations that you can perform. You can dynamically create your projects, models, and run the image jobs and all, right? Create images, create image jobs, etc. But in our use case, we are going to look into image analysis, right? So what you see here is that there are different sample code is also available for you to do. But let's go into the body and see what are the attributes. We saw compartment ID a few moments back. Then the features. Features is where you define what is the feature type that you are going to use. And then the image details. Image details is nothing but whether you are reading the image from object storage or reading from inline, right? If you're reading from object storage, then what are attributes you need to pass. And similarly, if you're sending an inline image, then your source will be inline, and then your data would be the binary, raw image data. And if I go again back to the features, you will see that the feature type could be any of these, right? You could have face detection, text detection, object detection, and image classification. Now, face embedding is something which I have not explored, so I cannot comment much upon this, but hopefully in future, I'll try and see if we can create a use case out of it, right? So if in our use case, we are going to see image classification, then we need to pass all these parameters, right? So I think this is good enough demonstration of the Vision service on the OCI console. And now I'll take you to the demonstration or the demo application which I created. So let me quickly demo you the app before we go into the technicalities. It's a simple application where you have an upload button. As soon as you upload an image, I'm showing that image first and then triggering the Vision API. And instead of image classification, I'm using object detection. So in my OCI demonstration, I incorrectly said image classification because for this image, I thought that the object detection gives you more, versatile result because in the image classification, it was showing human face, human head, etc., arms and all. But here, it gives you more practical approach to analyzing an image and rather the objects in an image. So this is not the response that you see in your OCI console because I have massaged the data which I'm getting from OCI console. And I'm trying to count the number of objects and display it here. So in a real world scenario, you can use this kind of approach in various um, use cases, right? Like counting the number of vehicles that are passing, or rather, number of objects on a conveyor belt, or number of fruits that are passing in a batch. So what you're seeing here is that it shows the count of persons, the number of footwears, and now no model is 100% accurate. This is one great example to prove that line, because there are five people. To an human eye, we are perceiving that there are 10 footwears, but the model is able to detect only eight. It could be because the tone of the shoe color is not different from the skin, and that maybe that could be the reason. Who knows, right? And then there are two chairs which are beautifully identified. And then it could be some fashion accessory which was detected here. There is a vase in the picture, and there is one house plant is what it's able to identify. Maybe it's not able to identify the other house plant, right? So this is out of box model from Vision API. You have all the flexibility in the world to create your own custom model, upload the train data, like the images that you want to train the model upon, and very specifically, you can ask the model to detect what objects you like in that image, right? And that would be more closer to your real world business implementation, right? So let me upload another image and see what happens. Now there are a bunch of people here. Again, it's able to determine that there are eight faces, and let's see, four and four, eight. Yeah, that is good. And then instead of man, three men rather, it is able to determine that there are two men, right? And there are three women, which is again incorrect. But it comes to the same concept of how good you are training your model to be, right? And this is a very generic use case, right? But if you go into industry specific use case, you can train your model to be very specific and very fine tuned for your requirement, right? And let's see if I upload another image. I have intentionally selected some tough examples, and here you see it's able to detect three umbrellas, and there are four persons which it is easily able to detect, and it could be the reason that there are blurred persons also in the image, and for a human eye it is very easy to identify, but for a machine learning model it may not be the greatest test image, right? And again, it's able to detect only one footwear, and it could be of any person, right? So this is the small demonstration of the of how you can call Vision APIs. Now, how did I implement is the first step is to create a connection, right? Now, as I told you earlier, you need to select which region you need to call in your service invocation. And then if I go here, you see I selected Ashburn, I guess. So that is somewhere in the list, right? So let's say if you select Mumbai, this is your endpoint, and then slash the version of the image, the service, right? So that completes my connection URL. And then I'm using OCI signature. So API signature, in other words, is the way I'm connecting to this service. And that is the go-to way to connect to any OCI service. And you need to provide your tenancy ID, user ID, then upload your private key here and your fingerprint. Once you are done, you can test it and complete the connection, right? So this connection I've created in the integration cloud, and the image or the application which I've developed is a VBCS application. So whenever user uploads an image, let me just quickly demonstrate that as well. Um, so I have opened my developer tools here, and let's say if I upload an image, what happens? So what it is doing is it is calling an integration in the backend. So if you go here, you will see that this is my integration URL, right? This is my integration endpoint, and I'm passing the payload the raw data of the image. So that's why you see gibberish here, right? And in the response, the integration is sending back the image objects and the name and confidence. One difference which you will see is that in our OCI console demonstration, you are having coordinates as well. Now, those coordinates are being returned in my invocation inside the integration, and I'm not interested to have the coordinates as a response because it makes the response bigger to parse and all, right? So what I'm doing is only selecting the relevant attributes from that response, right? So let me go back to my integration cloud, and so this is my integration, which I'm calling from my VBCS application, and the trigger is basically accepting a binary, right? I'm uploading an image directly, right? And in the response, I am keeping the response simple. I just need the name and confidence of each different object detected. Okay. In the next step, I'm invoking the API, which is using the connection which I just showed you, right? And how to complete the URI is you go here and then you find your particular URI that you want to invoke, right? So the connection had until here, and I'm just adding this URI in my invocation, right? So let me go back, and then you need to upload a sample request and response. The request is what you already I showed you that we can easily get from our OCI console, right? So this is a sample, okay? And here, although I'm saying object detection, in actual mapping, you can pass image classification and whatnot, face detection and whatnot, right? And then since I know that it's going to do an object detection, I have also configured my response likewise. If you are doing image classification, then your response changes. I'm doing this in order to capture the entire response. And finally, I'm interested only in sending the name and confidence, right? Although I'm not displaying the confidence in my application, but if you want, you can do that. And finally, I'll show you how I'm passing the image. All right, so this is the compartment ID which I'm using for this demo, and what I'm doing is I'm encoding it to base 64, okay? And the response which I'm getting out of this integration is basically I'm trying to, let me just filter out only the mapped fields, okay? So for each object that is detected from the response of the Vision API service, this basically does a for each loop. I'm mapping the name to the name and the confidence to the confidence. This structure is what we configured in the response of this in the first activity in this integration. All right, now let's go to the VBCS application. It's very straightforward. I'm just using a general overview page template. I have a button, an area to display the image, and then an area to show the object and their count. Right? It's a fairly straightforward implementation. As soon as you upload an image, the first thing I'm doing is calling this process image JavaScript function. This is required so that I can display the image on the UI, okay? And I'm storing the content in data, right? So if I go here and show you the image source, it is uploaded image. Now, how it is getting populated is inside the action chain. I'm uh, assigning uploaded image with the function calls result.data. That's where I'm, converting the uploaded image into what it needs to be. Right now, I'm calling the endpoint which I just showed you. This is the OIC integration, right? And in the body, I'm simply passing the file, the image which I uploaded, right? And if there is an error, I'm displaying the error to the user. And if the response is successful, what I'm doing is I'm passing the response, entire response to this function. And this is basically converting my the response payload into an object count kind of a hash map, right? This is what I'm using to display my data in the table, which is using the ADP variable, array data provider. And it is of this type, which is of count and object. So basically, what you need to just make sure is that what attributes you define here, they can be directly mapped to the ADP, right? So if I go back to the action chain, you will see that I'm passing the response. I'm just stringify the JSON response from my integration and passing to this function. This function is parsing the response, right? Looping over each object. And in the result, I'm just capturing the object and the count, right? So I'll also upload this code into a Git repo, provide the link so that you can also analyze and expand upon this use case, right? And then finally, I'm just providing the data to the ADP, and this ADP is then used to show the content in the table, right? So I hope you like this video, and I'll be uploading the code as I said in the Git repo. If you have any questions, then please do let me know in the comments. Thank you for your time.